Hey guys, my name is Danny Zuniga and I'm part of Challenge 2014 and I'm chilling in my room with my boy Brandon over there and my girl Jasmine. Hi Jasmine. And we're gonna do some calculus homework because we're cool. Alright. It says give a delta give a delta proof for the limit as x approaches to 0 of the function 2 minus 5x equals 2. So it's basically telling you that that's the case and you just have to prove that it's true. So our goal here, I wrote down a goal, it says prove that as x approaches to 0, the y values converge on a value as well. So basically what I'm saying is that the definition of a limit, that as x approaches to a value, y does as well. So to start off the problem, the format is, hold on, let me get my pen. Alright. The format is absolute value of f of x minus your limit should be less than epsilon. So that's what I did here. So if you can see my function, it's right here, 2 minus 5x, that's where I got this from. And then limit is 2. So now it's pretty obvious that the 2 and the negative 2, they cancel out. So now I'm just left with the 5x. And so it was negative, but I broke out the absolute value and now it's positive. And I had to add this side too, the negative side to the absolute value. So then I just divide both sides by 5 and I get the same, it's pretty much the same distance on both sides, it's just epsilon over 5 if you think of it in absolute value sense. So that's what I get for delta, which is basically my change in the x value. So that's going to be equal to epsilon over 5. And now to make sure that this is working, I have to prove it backwards. So we're going to work from this way upwards back to the original 2 minus 5x minus 2 less than epsilon. So we're going to start with our x minus a, and in this case it's the limit as x approaches to 0. So a here is 0. That's the a, it's x approaches to a. So right here we just plug in that 0, and then we got delta, and we know that delta is epsilon over 5. So now we have it set up, and now right here all I do is just cross out that 0 because it really doesn't help anything. And then to get the epsilon by itself, I multiply by 5 on both sides, on all three sides I mean. So here by 5, and they cancel, and I get whoa. Okay, that's not supposed to be it. Yeah. Alright. I don't know what, okay. So yeah, the 5 cancels, ignore these fractions. And then I multiply by 5 here, and I multiply by 5 here. But here doesn't do anything because it's 0. And then here we see, ignore the script, it goes to 5x. And then from here I can do an identity property of addition, I think it's called. So you can add 0 to any side by itself. So right here I added a 2 and I subtracted a 2, and I'm allowed to do that because that's equal to 0. And then, well, I didn't get the same as the other one because here it should be a minus. Up here it's a minus, right there. I didn't get a minus, but I'm thinking that since this is absolute value, that it wouldn't matter whether it's a minus or a plus, because these are 0 together. So whether this is a minus or a plus, when you take the absolute value, it's going to end up being a positive distance. So I did eventually get back to the original one right here, and it's in the same format. So we have a function right here, and then we have the limit, which is 2, and then that's minus, and then we have our delta, which is epsilon. Alright. I mean, we didn't have a delta, it's just epsilon, I'm sorry. So that's our epsilon. Alright, so now we have proven all that, we can make our if-then statement for our proof. So basically what I'm saying is that if...
Are you gonna wing the chemistry test?
if x is epsilon over 5 distance from 0, then y will be, then the function, the y value of the function will be epsilon distance from 2. And that's it, guys. Thanks.